quick tutorial that will help you get started and run your first test application on SimNG. I'm going to show you how you can parallelize an application and simulate it on the full system heterogeneous architecture. The sequential part of the application will run on the simulator for general purpose CPU, which is QEMU in our case, and the data parallel part will be offloaded to our 1000 core accelerator chip simulator, which would be running on GPU host platform. The accelerator chip has 4K nodes, where each node has cores, caches, scratchpad memories, all connected using a network on chip. So before we start, we should have CUDA and NVIDIA GPU installed on the system and download the copy of the latest version of SimNG from our website. Also, you need to have ARM cross compiler installed and set up a file system for QEMU using NFS server. I have it set up at the location right here. I have downloaded the latest version of the code in my home directory, and in here there are 3 main directories. The first one has the modified source for QEMU. SimNG has the source code for the accelerator chip simulator, and we will prepare our benchmark inside the directory benchmarks. The final binary of the SimNG that we will be launching is inside the main directory. So to prepare our benchmark, I will be taking a very small example of matrix multiplication. It's a C program in which we have the first matrix with 4K rows multiplied with the second one to create the result in the multiply matrix. After initialization, this is the main loop that we are going to parallelize. So for 4K rows, we will parallelize it on the 4K cores that are present on the accelerator chip, so that each node on accelerator chip will pick up an element from the row of the first matrix. Basically what we have to do is to parallelize this outermost for loop of the algorithm on 4K cores. We can do this easily with the help of a template file which is provided with this code. First we have to define our data structure here, and we declare our data structure at 2 different locations, and the parallel loop comes over here. So very similar to what we do in OpenMP, we create a chunk size that will be given to each core of the accelerator chip, and then we define our lower bounds and upper bounds. When call semi-hosting method will be encountered on QEMU, it will send the following parallel part of the application to GPU simulator until it is finished. And in the end, the control will return to QEMU, and we will be able to see the final results of matrix multiply. So finally our program would look something like this. We defined our 3 matrices inside this data structure. We have declared them at 2 different locations, and then we are parallelizing the data similar to OpenMP using the chunk size. So the chunk size given to each core of accelerator chip would be 1 in this case. Now to compile, first make sure that you have the environment variable for ARM compiler set to its correct location. This is where I have installed my ARM compiler, and then run a compile benchmark script. You have to provide the name of the benchmark as parameter. and also the number of cores that you're going to parallelize your application for. This will create the application binary in the file system directory of QEMU. You can see it here. It has created a binary matrix multiply underscore template. Now that the test binary is created, we can launch our QEMU first. But before we do that, we have to copy a device driver and its load script into the file system home directory of QEMU. So copy GPU sim underscore dd.ko and module underscore load.sh into the home directory of the file system of QEMU. Once that's done, we can launch QEMU using the script. This brings up the QEMU. We go to the home directory and load the device driver. On the other hand, we can launch our accelerator chip simulator for 4000 cores and the full architecture. Architecture 4 has network on chip, core caches, and complete architecture. If you want to create a log file, add parameter log with the script. This will boot our accelerator chip simulator SimNG. The SimNG will wait as a server to receive command from QEMU. So we will be running our test application from inside the QEMU. So we go back to the binary that we have created and we run it from inside QEMU. Now we can see that the parallel part of the application is currently running on SimNG, and once that is finished, the control will return back to QEMU and it has started printing the results of the output matrix. On the SimNG side, we can see that a total of 50 million instructions per second performance was achieved, and it took 8.3 seconds for the GPU kernel to finish simulating. This was a small benchmark where each core on accelerator chip runs a very small portion of the computation. For longer running benchmark with a bigger data set, when it is parallelized, we can achieve as much as 100 million instructions per second with full architecture, and with the simple architecture without the cache and NOC, we can get up to 600 million instructions per second. So QEMU has also finished its sequential part of the code, and the whole benchmark took 31 seconds to finish on the entire heterogeneous system architecture. To kill safely the accelerator chip simulator, there is a binary that we have provided with the code. Just kill and you can continue working on the QEMU from here. So if you need further details on parallelizing and how to modify and build our code from scratch, please look at the user guide and manual provided with the source code and at our website esl.epfl.ch. Thank you.